Hello again, everybody. We're now working on the next lesson area of trapezoid and a kite. So our goal for today is to find the area of a trapezoid by decomposing into regular polygon. Again, the word decomposing is mean break apart, put them into to regular polygons. It's easier for us to solve it. Right, so that's decomposing. So if the figure is complicated and we could cut them into different shapes, regular shapes like rectangles, square, triangle, it's easy for us to solve instead of memorizing the formula. So I always like to decompose the lessons, the shapes or the figures, to solve for it. Okay, but before that, we could have a challenge question first. A painter has 3 gallons of paint. Each gallon covers 350 square feet. Will the painter have enough paint to cover the wall with the dimension in figure A? And explain. I'll give you a minute to work on it. Let's try. And I will show you guys the answers of my sentence. I have here an answer. This is from Selena. So she did 350 times 3 to make it 1,050. She got that from here. 3 gallons of 350 quarts of square feet. So that gives the area for the paint that could be covered by 3 gallons will be 1,050. The area of this trapezoid, what she did is she cut this into 3 shapes: the triangle, the rectangle, and a triangle. So here is 132 times 2 equals 264. Where did she get 132? So if you look over here, it is 11. You could have 11 times 24. She should have put 11 first, times 24, right? Divide by 2, so 11 times 24. 11 times 24, but she didn't show us that she did it, but she might did it the other way that I was thinking. So 11 times 2, that is for the triangle, right? So that gonna be 132. 11 times 24 is 264, divided by 2, all right? So that gives us 132. But since there are 2 of them, this one and that one, so she multiplied it back to 2 because there are 2 triangles to get 264. And then this 24 times 36 is this area of the rectangular shape and gives us 864, and she added it up to get 1,128. So not enough to cover because the area of the figure is bigger or needs more paint than the available gallons of paint. All right, let's look at this other example. All right, so she multiplied 11 times 24, so it's 11 times 24 equals 264. If you notice, it was not divided by 2 because this could be carried over here. All right, that is identical. We know it's identical because that's 11 and that's 11. So we could carry it over here. So that is already gone. So that is, she was able to solve for the area of 24 and 36 and 11 times 24. So 264 and 268, and we added it equals 11 and 1128 or 1,128, and it's not enough. The paint is not enough to cover that shape. There's one more thing I would like you to look at the example. I want you to look at this. Here's another example in how to solve this problem. I forgot if there is one particular student that did this way. I think in my other class. So remember when I tell you that you could move this here, right? And the shape becomes, the shape will become like this. So here, you know that you have that shape, right? And then you add this part because you moved it. So with that said, our length becomes 36, and we know that that's 11. and we also keep the height, which is 24. So now we have the new length, 36 and 11, that gives you 47, right? So from here to here is 47. Where did we get that? It's the 36 and the 11, so that gives you 47. So now we could use the formula, just length times width. We don't really have to figure out the formula for the trapezoid to solve this problem, right? But again, this will not happen all the time because some trapezoids are not equivalent sides. So just double check all the time, warning, because some trapezoids have longer, so you have to really break it into a triangle 1, a rectangle, and a triangle 2. But if it happens that the length of the base is the same, that will tell you that that's identical triangle, that we could create another rectangle out of it. So now we could just say the area for this trapezoid is 24 times 47. That will definitely give you the same answer. Again, be careful to check if they are twin. They are the same triangle. And we still get an answer of 1128 or 1128 square feet, and which is bigger than the covered area of a paint. All right, so let's try to see the lessons that was given with Envision and how to solve trapezoids, area of the trapezoids, and also a kite in some point of the lesson. So here's our example 1. What do you know about the top side of the trapezoid and the lower side of the trapezoid? We already know that are parallel to each other. But let's check the lesson itself. So a trapezoid is a special quadrilaterals. So we're going to check how we're going to find the area of this trapezoid. We already did this in our challenge question, but let's just look at it again, okay? So in this problem that we have, the pasture is in the shape of a trapezoid. The trapezoid is a quadrilateral that has only one pair of opposite sides that are parallel. So what do you think is the area of this pasture? So we can solve the area of the trapezoid by decomposing it into two triangles, like the one that we have here. So we know that that's 10 and that's 18, and we could make parallel sides over here to make it two parallel sides over there. So we could create a triangle, a rectangle, and another triangle. So we know that this triangle is 4, and that's the others. If that's 4, that's also 4. So we'll find the area of the first triangle, the rectangle, and the other rectangular side. Exactly the same challenge that we had a while ago. So if you look at this point of the example, we have the triangle over here and labeled it 412. And since this is 4 and we know that this is a special trapezoid, that the sides are the same, so that's also 4, that will consist 18. So 4, 10, and 4. Where did you get 18? That was the original length of the base. Alright, I want you to look at this example. Alright, so the area of the base is 1/2 4 times 12. We're gonna have 24 square yard, and the rectangle becomes 120 square yard. So we're gonna add the area of the triangle.
The area of the pasture is 168 square yards.
So we said, so we add, so we could add all the different shapes, the triangle, the rectangle, and another triangle. So the triangle is 24, but there are 2 of them, so we add 24. And the rectangular shape is 12 times 10, 320. So we added up is 168 square yards. So that's an example 1. Let's look at example number 2. Alright, so we have example number 2. A builder needs to cut one stone in the shape of a trapezoid to fit in the space. What is the area of the front of the side of the stone? Do you see the front side of the stone is in a trapezoid shape? So let's find the area of this trapezoid. Again, looking back, a builder needs to cut one stone in the shape of a trapezoid to fit in the space. What is the area in the front of the stone? Let's look at the shape again. So reconstructing the shape, we have it this way. So remember the trapezoid that we had before, the triangles are the same. At this time, they are not. So we cannot just move this over here and make it one rectangular shape. That we cannot do. This time we really have to solve for the area of this triangle over here, area of the rectangular shape, and the area of that triangle on this side. Let's work on that. So we know that we could find the area of this triangle over here. So it's a triangle, so it is base times height divided by 2. And let's substitute the value. This is our base, that's our height. So we're going to have 4 times 5. We divide it by 2 because it's only half of that rectangular shape, remember? So now the area for this triangle is 20 divided by 2. That gives us 10. So I'll put 10 here just for me to remember that that's the one. For this side, we have the area. I'll solve it here. Equals length times width. We know that the length is 6 and the width is 5. So we could just say 5 times 6. And this point, that gives us 30. This area over here, I cannot make it 10 again because they are totally not the same. Look at this, the base. This is 4 and that's 2. So this triangle, we could say 5 times 2. We divide it by 2. So do mental math. 5 times 2 is 10, divided by 2 is 5. So this area over here is 5. So we'll find the total area of this trapezoid. We're gonna have 10 plus 30 plus 5. And that will give you 45. And the units is square inch or square inches. It's 45 square inches. So we're gonna add a total shape. This is what I like with decomposing because I don't have to memorize the formula of a trapezoid, but you could always do that. You could always solve this using the formula of a trapezoid. I'm gonna clear this and I'm gonna show you a formula of a trapezoid just for the sake of seeing if they will give us the correct answer, or I mean exact answer. So we know that we have 45. Let's see if it has the same. I am showing you the formula of solving a trapezoid, but just for the sake of seeing if they will really get the correct answer, or I mean the same answer is 45. So the formula will be area is base 1 plus base 2 divided by 2 times the height. Base 1 and base 2 are those two sides that are parallel to each other. In this case, it is 6 and 12. So in this case, that's gonna be 6 and 12. That's gonna be your B1 and that's gonna be your B2. Okay? Alright, let's try to solve it to prove that the answer is 45. So B1 is 6 plus the B2 is 12. And we know that we have to divide it by 2 based on the formula. Let me erase that one. And then we multiply it to whatever the height. The height is 5. So using your magical calculator, magical tool as I always say, 6 plus 12 is 18, right? Divide by 2 times 5. We know that, let me make my pen smaller. So 18 divided by 2 is 9, and times 5, that's definitely give us 45. So With that said, you could use this formula, but we usually forget that there is a formula. We could always decompose the shape in order for us to find the area of any kind of shape. Trapezoid, parallelogram, irregular polygons, name it. Break it into small pieces of regular polygon and you could solve it easy. Then add it up. Alright? Okay, so let's see if we could have another example. Alright, we have example number 3. A kite is a quadrilateral with two pairs of adjacent sides that are in equal length. So Jackson has a rectangular piece of cloth that has an area of 298 square centimeters. Does Jackson have enough cloth to make the kite shown over here? Let's see. So here's our kite. We would like to see if the 298 square centimeters that Jackson have will be enough to cover this. We can solve the area. We'll do it in 2 ways this time. We could do it more ways. You could solve it using 4 triangles. You could do it with 2 triangles, vertically or horizontally. Let's just make it in 2 ways. All right, but you could do more than 2 ways. So the first way, I would like to cut this into vertically. We'll cut it vertically. So they are identical again. They are identical if I cut them this way. Okay. So there are 2 identical triangles. So here I cut them into 2 triangles, but remember where your height is. The height will always be where your right angle stands. So in this case, our height will be here. That's where your right angle gonna be. All right, this one is 5 and that was is 25, so the total of 30. So the shape gonna be look like this. All right, so that gonna be 30 and your height will be 10. So since that is still a triangle, so the area will be base, which is 30. That's from 5 and 25, that becomes 30. Okay, times 10, and since it's a triangle, we divide it by 2. So that gonna be 30 times 10 is 300 divided by 2, that gives us 150. But again, this is identical, so there are 2 of them. So this is 150 and that's another 150, the area of this shape. So the total area is still 300. 150 plus 150, and the unit is centimeters squared. All right, so that's one example. Let's see another one. Let's clear this out and we'll solve it in another way. So this time I could cut it in horizontal way. So I could get this triangle and I could get this triangle. So let's solve for triangle 1. We know this is 10 and that's 10. If you look over here, just my line was not straight. So make it straight, So okay, so that's 10. So become 20 is the base and the height is 5. So the first one is 20 times 5. And it's still a triangle, so we divide it by 2. So now we have 20 times 5 is 100. And divided by 2, we end up with 50. So that's for the top one. Let's solve for the bottom one. The bottom one will be 25. For this one, the base will still be 20 and the height will be 25. And we divide that by 2. So 20 times 25 gives us, that will give us 500. With your calculator, you want to check, and we divide it by 2. So that's gonna be 250.
Mommy.
Okay, that will be 250. So now we're gonna add them up. So the area for the top one is 50 and the area for the bottom triangle is 250. We're still gonna end up with 300 and our units is still the same. So there we go. It's 300 square centimeters. One more way of solving this. Let's look at it. Let's clear this one out. One last way that I could like tell you is like you could move this over here, and that's gonna create something like this, right? I'm not straight, but yeah, like that. So you were able to create a rectangular shape like this, but you have to erase that one. And this one, you could move it over here. Okay, so that gonna look like this. Wait, make it. And the bottom one gonna look like that. I'm just gonna make it bigger. So it looks like you're gonna end up with a rectangular shape. See that? You move this over here and you move that over there. Then you're gonna end up with 30. So your height gonna be 30. That's over here. It's already shaded for you. It was 30. And your length will be 10. So it looks like you have 30 times 10 gives you 300. So you were able, or we were able to solve it in 3 different ways, but we got the same answer. Alright, so I hope you learned something from this one, guys. Like decomposing, I love decomposition rather than memorizing the formula. Alright guys, I hope you learned something today from our lesson, decomposition, finding the area of a trapezoid and the kite. With that said, I want you to explore in Envision and Savas and check Google Classroom for the details of your work. And thank you very much, everybody. I'll see you again for next lesson. Enjoy your day and have fun learning math. Love you guys. Bye-bye.